So Bernoullis theorem is nothing but application of work energy theorem for fluids basically, and in our context we are talking about liquids. Okay, so let us first see how work energy theorem is there in Bernoullis equation. So suppose this is some liquid which is flowing in some tube. All right, so this is a reference line. Okay, we are considering 2 points. We are considering 2 points. One point is A and one point is B. Okay, okay. Height of point A will be treated as HA. Height of point B will be treated as HB. Okay. Now pressure at point A is PA. Pressure at point B is PB. Okay. Velocity at point A is VA. Velocity at point B is VB. All right. Now, by work energy theorem, what we can write? By work energy theorem, what we can write? So by WET, W all is equal to delta K, and delta K is what? Ke final minus Ke initial. Ke final minus Ke initial. All right. Okay. Now, when we are saying work done by all the forces, that means work done by pressure plus work done by gravity. Okay, because gravity is one force which is acting, pressure difference will be causing its own work done. So work done by pressure plus work done by gravity is equal to delta K, and delta K is half mBVB square minus half MA VA square. Okay, because final kinetic energy is half mVB square and initial kinetic energy is half MA VA square. All right. All right. Okay. So now work done by pressure is how much? Okay. Pay attention. So due to P pressure, suppose at A it is moving dxa. It is moving how much? Dxa. Okay, so dxa will be nothing but va into dt. dxa will be nothing but displacement is equal to velocity into time. Similarly, dxb will be nothing but vb into dt. dxb will be nothing but vb into dt. Okay. Okay. So how much is work done in due to pressure here? So that will be PA, okay, dW actually, dW at A. So dW means force into dx. So F at A into dx at A. Now FA is PA into AA into dx. Correct. So this will be PA into AA into dx. Now this is work done at A minus PB into AB into DXB. PB into AB into DXB. Okay. How much is work done by gravity? So work done by gravity will be, let me write here. Work done by gravity will be final potential energies MB into G into HB minus initial potential energies MA into G into HA and with a minus sign and with a minus sign. So that will be minus of MB into G into HB minus MA into G into HA, and that is equal to half MB VB square minus half MA VA square. Please note this, everyone. Please note this. Please note. Okay. Any doubt, any questions so far? All right. Now try to understand what is AA into DXA. AA into DXA means volume, dV. AB into DXB is also volume. All right. So let me write it as AA into DXA is equal to AB into DXB, and that is dV, volume of liquid which is entering, and that is same as volume of liquid which is exiting. So PA into dV minus PB into dV minus, listen very carefully, rho into dV. Okay, I am writing MB as rho into dV into G into HB minus rho into dV into G into HA is equal to half into rho into dV into VB square minus half into rho into dV dV. V is volume here. Okay. Minus half into rho into dV into VA square. If you have any doubt in this step, please feel free to ask. I have simply written m is equal to rho into dv and a into dxa also as dv. Okay. Why I have written it like this, you can realize, you can understand. Now I can cancel dv easily from both sides. Now I can easily cancel dv from both sides. Okay. So pay attention. So this dv, this dv, this dv, this dv, this dv, this dv got cancelled from everywhere. Okay. So what do we get after that? PA minus PB. Okay. PA minus PB minus rho GHB, and this will be plus actually, plus rho GHA is equal to half rho VB square minus half rho VA square. Okay. Now from this, in next step, what we can write is, pay attention everyone, PA plus rho GHA plus half rho VA square is equal to PB plus rho GHB plus half rho VB square. Okay. Now, what exactly this is telling us? Pay attention, everyone. P plus rho GH plus half rho V square at any point is equal to P plus rho GH plus half rho V square at any other point. So basically it is telling us that P plus half rho V square plus rho GH is equal to constant. Okay. So basically that is telling us that for any fluid, for any liquid, pressure at any point plus half rho v square at any point plus rho gh at any point is equal to constant. Please note everyone. Please note. Noted everyone? Noted. Okay. So this is the derivation of Bernoullis theorem, Bernoullis equation basically. Okay. So please note, according to Bernoullis theorem, sum of pressure, sum of pressure Ke, or you can say kinetic energy, sum of pressure, kinetic energy and potential energy head. Potential energy head at any point, at any point in a liquid, in a liquid remains constant, remains constant. Okay, so for any liquid which is flowing, sum of pressure head, kinetic energy head and potential energy head, sum of all these three remains constant. Sum of all these three remains constant. Okay, so this is pressure head, this is Ke head and this is Pe head. Okay, Pe head is the part which comes through potential energy, Ke head is the part which comes through kinetic energy and pressure head is the part which comes through pressure. Okay, apart from this there is one very important point. Bernoullis theorem or Bernoullis equation, Bernoullis equation, Bernoullis equation is applicable. Bernoullis equation is applicable only for streamlined flow, streamlined flow of ideal non-viscous, ideal non-viscous incompressible liquid, incompressible liquid. So these conditions should be met only when we can apply Bernoullis theorem. Which are the conditions? Number one, flow should be ideal, liquid should be non-viscous and incompressible. Okay, if these conditions are meeting, then only we can apply Bernoullis theorem, otherwise we cannot. Please note, please note. Okay, please note. Now let us solve questions based on this question. This is a tank.
So what
What
is scroll up?
is it sufficient?
Yes, sir.
So this is a liquid which is of density rho and it is filled in a vessel. Okay, this is large tank. Okay, so the question is, a liquid is filled, a liquid is filled in large tank, up to height h, up to height h, a small orifice, a small orifice is made at the bottom, a small orifice is made at the bottom. Find speed of liquid, find speed of liquid coming out of orifice, coming out of orifice. Please find, please find everyone. Yash is asking, and he asked quite late. Sir, why WP is greater than A? See, if WP is not greater at A, then how liquid will rise up to point B? WP at A has to be more for the liquid to rise up to B point. Okay. Okay, everyone, please pay attention. Enough time given for you to attempt. Pay attention. This is point A, which is opening in air. This is point B, which is also opening in air, right? So if we are applying MEC, so by MEC between point A and B, so what we can see, pay attention, PEA plus KEA is equal to PEB plus KEB. Okay. Now if this is the reference line, so PEA is equal to, in fact, rather than applying it like this, we should apply Bernoullis theorem. Bernoulli theorem. By Bernoullis theorem between A and B. So PA plus half rho VA square plus rho GHA is equal to PB plus half rho VB square plus rho GHB. Okay. So PA is how much? PA is the pressure which is in air. So that is P naught plus half rho VA square. Now you tell me, I am asking you a question. If you have a large tank at the top of your building and you have opened a tap, you have opened a small tap. Okay. So will the height of liquid fall very sharply, or you will not be even able to observe that what is the height change? If the tank is large, you won't be even able to observe. So half rho VA square will be negligible. Half rho VA square will be negligible. Right? Okay. So P naught plus half rho VA square has become negligible plus rho GHA. So that will be rho into G into capital H is equal to PB. Now B point again is opening in air. B point again is opening in air, so that will be P naught plus half rho VB square. That is what we need to find. So half rho VB square plus rho GHB, that will be 0 because B point is at reference line. B point is at reference line, right? Now if you see both sides, P naught got cancelled, rho got cancelled, this was 0. So VB comes out to be under the root of 2GH. The velocity of liquid coming out will be under the root of 2GH. The velocity of liquid coming out to be under the root of 2GH. Okay. This velocity is called velocity of efflux. This velocity is called velocity of efflux. Please note everyone. Please note. Please note. This velocity is called velocity of efflux.
So can you repeat why rho GHB got cancelled?
See, P naught, both sides got cancelled. Hello.
Yes, sir.
P naught gets cancelled. Is there any doubt in that?
No, sir, I'm talking about the previous thing, rho GHB.
Rho GHB because B point is at the reference line. So potential energy will be 0 if the object is kept out at reference line. That's why.
Okay, sir. Thank you.
Okay. Noted, everyone? Noted, everyone? Say yes, sir.
Yes, sir.
Okay, good. Now, I'm giving you the same question once again, but with a slight change. This time, I'm not mentioning that tank is large, and this time, I'm also giving you area of the small hole. This is small a, and this area is capital A. This area is capital A. Height of liquid remains same. Density of liquid remains same. Okay. This is a tank. I have removed the word large. Question says find speed of liquid coming out of tank. Find speed of liquid coming out of tank. Please find. Find speed of liquid coming out of tank. Rohit is saying root of 2gh plus ua square. Hmm. Okay, everyone, please pay attention. So again, we are applying Bernoullis theorem between point A and B. Okay. Point A is opening in air. Point B is also opening in air. Point B is at reference line. Okay. So by Bernoullis theorem, by Bernoullis theorem. So PA plus half rho VA square plus rho GHA is equal to PB plus half rho VB square plus rho GHB. Okay. Now pay attention. Pressure at A and pressure at B both are opening in air. So it will be P naught plus half rho VA square. It will have velocity, we don't know how much, plus rho GHA. So that will be rho into G into capital H is equal to PB is P naught half rho VB square. That is what to be calculated. Half rho VB square plus rho GHB is 0 because that point is on reference line. That point is on reference line. So now P0 got cancelled. 0 was anyway cancelled. Okay. So pay attention further. So VB square, if we cancel, we can cancel rho also. VB square is equal to VA square plus 2GH. VB square is VA square plus 2GH. This is equation number 1. This is equation number 1. Okay. Picture abhi baki hai. Now the next thing which you can do, suppose this is coming down with VA. This is coming down with VA and this is coming out with VB. So one more thing which you can write is by continuity equation. By continuity equation. And what you can write is capital A into VA is equal to small a into VB. Okay. Area into velocity at A point is equal to area into velocity at B point. We learned this in the last class. We learned this in the last class. Okay. So what we can write is VA is equal to small a by A into VB. This is equation number 2. This is equation number 2. So now from 1 and 2. From 1 and 2. So what we can write from 1 and 2? Now you can put value of VA. So VB square is equal to VA, means A by A into VB square plus 2GH plus 2GH. So that gives us VB square in the bracket 1 minus A square upon A square is equal to 2GH, and that will give us finally VB is equal to 2GH upon 1 minus A square upon A square under root of that. Under root of that. Please note. Okay. So VB is equal to this. Please note, everyone. Please note, everyone. Any doubt, any question? Good. Now in this, VB is equal to under root of 2GH upon 1 minus A square upon A square. If you put small a is equal to negligible, please put that. I want you all to do it by yourself. If you put small a is equal to negligible, see what answer you are getting. Check what answer you are getting if you put small a is equal to negligible. You will get exactly same answer as previous question. You will get exactly same answer as previous question. Right? Please note. All right. Okay. Good. Let us move further. Let us move further. Question. Here velocity is V naught and area is capital A. Here area is small a. Okay. Here there is some height, let's say HA. And here there is some height, let's say HB. Okay. Question says find difference of height of liquid. Okay, this point is B. Find difference of height of liquid find difference of height of liquid at 2 points A and B. Okay, so how much is the difference that you need to tell? How much is the difference you need to tell? Please find. Okay, everyone, enough time given. Pay attention. I am considering this line as the reference line. I am considering this blue line as the reference line. Okay, all right. So now what you can write is there are two things which you can easily apply. By continuity, by continuity. So by continuity you can write capital A into V naught, okay, is equal to small a into VB, and that gives you VB is equal to capital A V naught upon small a. This is the first thing which you got. VB is equal to AV naught upon small a. Okay. Now comes the second thing, which is Bernoullis theorem. So by Bernoulli, by Bernoullis theorem. So what Bernoulli says, plus half rho VA square plus rho GHA is equal to PB plus half rho VB square plus rho GHB. Okay. Okay. Now, first of all, A point and B point both are at same horizontal level. A point and B point are at same horizontal level. So your rho GHA and rho GHB, these two will get cancelled. Are you getting this? All right. Because I am talking about this height. Here HA means height of point A, not this HA. Be very clear. Okay, let me use a different symbol. Let me use a different symbol so that it becomes more clear for you. This is capital HA and this is capital HB. Capital H means height of point A and this point B. Okay, and this got cancelled. Now, what is connection between VA and VB that we have seen? We can put the value of VA and VB also. Okay, so let us put value of VB from equation 1. So when we are putting value of VB, we are getting PA plus half rho VA square is equal to PB plus half rho VB square. VB square means A V naught upon A whole square. Okay. Okay. So from this, pay attention. What you are getting is PA minus PB is equal to half rho V naught square because VA is V naught. VA is V naught and that will be A square by A square minus 1. A square upon A square minus 1. Now let us see how much is PA and how much is PB. How much is PA and how much is PB. Okay, let us see. So pay attention. Once again, come back to the diagram. This point has pressure of P naught because it is opening in air. This point also has pressure of P naught. Okay, this is PB. So PB is nothing but P naught plus rho GHB. PB is nothing but P naught plus rho GHB. All right. Similarly, if we talk about PA, this is PA. So PA is nothing but P naught plus rho GHA. P naught plus rho GHA. Okay, so let us put these values. Let us put these values. So from here we can write P naught plus rho GHA minus P naught minus rho GHB is equal to half rho V naught square A square by A square minus 1. Isn't PA is equal to P naught? No, actually it is not. It is not. The pressure at the topmost point, which is opening in air, is P naught. It is not opening in air. It is a part of tube, Aditya. It's a part of tube which is not shown to you. Okay. It is a part of tube, long tube, already existing. Okay. Now pay attention here. What you can notice is P naught got cancelled. Okay, rho got cancelled. Our task is almost over. So G times HA minus HB is equal to half V naught square A square upon A square minus 1. So HA minus HB comes out to be HA minus HB comes out to be, so delta H is equal to HA minus HB is equal to V naught square upon 2G A square upon A square minus 1. This is the answer. This is the answer. Please note, everyone. Please note. Please note. Any doubt, any question? Say yes or no. Okay, good. Yash is saying, sir, how rho GHA and rho GHB got cancelled? First of all, we are not cancelling rho GHA and rho GHB. We are only cancelling rho. And after that, what is left is G times HA minus HB. Only rho is getting cancelled. Yes. Rho GHA is not getting cancelled. Okay. Say yes, sir. Okay, good. Only rho part is getting cancelled. G into H is remaining. That's why in next step we have taken G into HA minus HB as common. Okay. Okay. All right. Let us move further. Let us move further. Next question. This is a room. Okay. And this is a ceiling, or you can say roof basically. This is roof which is detachable. This is detachable. Mass of this room is m and area of this roof is a. Okay. Mass is m and area is a. Okay. Now wind is blowing. Wind is blowing with speed v naught. Okay. If density of wind is rho, if density of wind is rho, find find minimum speed of wind, find minimum speed of wind to lift the roof. Okay. Find minimum speed of wind to lift the roof, and that can happen in real life also. That can happen in real life also. Please find. Okay, everyone, please pay attention. So we are considering 2 points. One point is A and one point is B. So this point A is just above the roof and B point is just below the roof. Okay. So what we can do, we can apply Bernoullis equation. So by Bernoullis equation between point A and B. So PA plus half rho VA square plus rho GHA is equal to PB plus half rho VB square plus rho GHB. So first of all, you can very well see that A and B points are immediately above the roof and below the roof. So height difference is not much. So rho GHA and rho GHB are cancelling each other. Rho GHA and rho GHB because both are at same almost same level of height. So these two things are equal. Okay. Now you tell me inside the room, will there be any wind? No. So how much will be velocity of wind inside the room? It will be 0. Because velocity of wind is 0 inside, right? Okay. So what you can see is delta P is equal to PB minus PA. Delta P is equal to PB minus PA, and that is equal to half into rho into V square. And wind is blowing with speed V0, so let me use V0. Okay. So this is delta P. Now pay attention. If the roof is being blown, then mg will be acting downward and delta P into A must be acting upward. So for just lifting of roof, for just lifting of roof, so delta PA which is upward minus mg which is downward must be equal to 0. Alright. So delta P, how much is the value? Half into rho into V0 square into A. A is how much? A is the area. A is the area and that should be equal to mg, right? So from here V0 comes out to be 2 mg upon A rho root of that. So this much should be the velocity of wind to lift the roof. Okay. Just to tell you, this effect is called Magnus effect. This effect is called Magnus effect. Okay. And it is the same principle using which aeroplanes are lifted up. It is the same principle using which aeroplanes are lifted up in sky. Okay. Please note everyone. Please note. Okay. 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 So that is enough for today. We'll study further in the next class. I hope you all have noted.
Thank you, sir.